Hello everyone. Today we will explore some of the ideas related to Python classes. So let us go around and write a Python class. So we have already seen classes, and so let us write a class which is a rectangle. Okay, class rectangle. So basically, right, that's a syntax, and I need an init. So here we'll pass for side 1 and side 2, which are the sides of the rectangle, init with 2 underscores, right? And so now we will attach to the sides to the self. So I can either say self, I can create 2 new attributes, right? I can maybe call side 1 and self dot be equal to side 2. So that is my init. So let us create more methods, maybe the area. So the area is simply side 1 into side 2, right? So return side A. This is the area. Let us calculate the perimeter, which is sum of all the sides. So we can say return self dot A, right, plus self dot B star 2, or self dot A plus self dot A plus self dot B plus self dot B. So this is a rectangle, so we can create a rectangle, right, equal to, let us 10 and 15 be the sides. So we have rectangle dot A, rectangle dot B, which are 10 and 15. So now we can see if it is working. We can calculate area, right, comma dot perimeter. So we get 150 and 50, which seems to be fine. So now let us create another class. So we will call it a square. Okay, the thing I want to do is I put rectangle in parentheses after square, like a function, but it is not function, it's still class. And we'll create the world's smallest class ever. Just put a pass. Remember, pass means I can add in the details later, so it is just a definition without anything in it. So which basically already created a class called square, which when I put something in parentheses, which means that the square class is a subclass of rectangle, and or I can also say rectangle is the parent, square is the child. And the point is, since rectangle is the parent, square gets everything from rectangle. Rectangle is a very nice parent, you know, and everything means all the methods, which means I can right away go and create a square, right? So of course we need 2, right? 2 in the init, in the rectangle we have side 1 and side 2, so 20 20. So now I can say square 1 dot area and square 1 dot perimeter, right? So we get 480. So now we created a child. So we already showed the idea of inheritance, right? So a square gets everything. Square gets the 2 methods, area and perimeter. It also gets the attributes, right, A and B. So everything he got. Now let us put let us go and add some methods here. So first of all, we can see that he gets everything from his parent or her parent, right? So square gets everything. So now let us create we'll create his own methods, maybe diagonal, right? So it's called self, and we need to we can say return self dot A star 2, that's square, a square plus b square, root of that, right? So now I have, if I create my square, I get square dot area, right, and also the diagonal. So we created a new method for square. So square now have all the methods from rectangle and also the diagonal. Now if I try to call from rectangle, if I to call the diagonal, right, it creates, it says rectangle object has no attribute diagonal. So that is the idea. So now let us see. So we create a new method here. So now let us say we can also override the methods in square. Let us take the init, for example. I say init, and I want to call our square with only one side, right? We don't need two, so I'll just call side. Now I can say we need also the self.a and b, for example, to calculate other cells. So I say self.a equal to side, and maybe self.b equal to self.a, or side itself, you know. So now let's see, create a square with side. So square, so here we now only need one, right? As I said, that was what was our aim. So now I can say square.area. See, everything is working as before. So basically we took the init, which and we now have the same name. So which means that now the init in the superclass is not working. Square defined his own init, right? So now let us also, we don't have to do this way. We can also call the superclass method for the rectangle class. I can say something like rectangle, right? Called, so I can call the rectangle call dot init, right? Now I'll pass self, and I also pass side comma side, because in the rectangle we have both sides, right, for the init a and b. So I pass that, and now if I call, see, so this is also we can also call the superclass methods like that. So we override the init method. Also inside init we called it so that it works. So that now we get the self.a and self.b through the superclass init. So now let us write another method, you know, for example, one more we'll create. For example, I want to say take area. I want to totally change the behavior of the area. I want to override what is already in the rectangle. I want this own behavior. For example, earlier it was returning back. Now I'll just say print maybe area, this like that. So now I instead of returning back, it is calculating the area, which is basically the square of a, self.a, right? And it is printing it. So I create my square, right, and I say square dot area, for example. Now you see it basically performed this action, and it is not returning back anything. That's why I get none. So, and if you go and look at the rectangle dot area, and that is like that, and square dot area is simply, it is performing a print. So we completely override the area behavior of the method area in the child by redefining it inside the child. So these are some of the ideas related to inheritance and overriding the superclass method. So there is subclass and superclass, or the parent and the child. Thank you very much for watching.